All right, so we've seen how to plot a vector when we're given an initial point and a terminal point. However, because a vector can be placed anywhere in the plane, it may be easier to perform calculations with a vector when its initial point coincides with the origin. So we call a vector with its initial point at the origin a standard position vector. So because the initial point of any vector in standard position is known to be 0, 0, we can describe the vector by looking at the components of its terminal point. So if a vector has its initial point at the origin and its terminal point at a coordinate x, comma, y, we can write it in its component form. So let's go ahead and sort of write out these definitions. So we call a vector with its initial point at the origin a standard position vector. All right, so from there, if a vector v has its initial point at the origin, and terminal points at the coordinate x, comma, y, then we can write the vector in what's called component form. So instead of using parentheses for our coordinate, we're going to use these triangle brackets, comma, y. All right. So when a vector is written in component forms like this, the scalars x and y are called the components of the vector. We kind of just throw in that bolded word as well, the definition. So a vector with initial point 0, 0 and terminal point x, comma, y. So the scalars x and y are called the components of v. Awesome. All right. So recall that vectors are named with lowercase letters in bold type or by drawing an arrow over their name. We've also learned that a vector can be named by its component form, with the coordinates of its terminal point in angle brackets. However, when writing the component form of a vector, it's important to distinguish between the angle bracket x, comma, y and the parentheses x, comma, y. So the first ordered pair uses angle brackets to describe the vector, whereas the second uses parentheses to describe a point in the plane. So the initial point of the vector x, comma, y is the origin, 0, 0, and the terminal point of vector x, comma, y is the point x, comma, y. So when we have a vector not already in standard position, we can determine its component form in one of two ways. We can use a geometric approach, where we sketch the vector in the coordinate plane and then sketch an equivalent standard position vector, right? Just kind of move it down to the origin. Alternatively, we can find it algebraically, using the coordinates of the initial point and the terminal point. So to find it algebraically, we just subtract the x-coordinates of the initial point from the x-coordinate of the terminal point to get the x component. Then we subtract the y-coordinate of the initial point from the y-coordinate of the terminal point to get the y component. So here's a rule then that we can use. Let's go ahead and write that out in specifics. All right, so let v be a vector with initial points x with a subscript of I and y with a subscript of I for initial, and terminal points the x with a subscript of t, comma, y with a subscript of t for terminal point, right? Then we can express the vector, bold V, in component form as the bold vector V equals, using our angle bracket, so we're going to take the difference of the x coordinates, x terminal minus x initial, gives us our x component. And then for the y component, we're focused on the difference of the y values, the y terminal minus y initial. And there we have it. That's how we have our component form of a vector.